So I think that's all I got, but yeah, welcome.
Thank you. Great job, right? Thank you, everyone. It's really fun to be here. I appreciate the invitation. It's a great privilege to present this in front of you. I have presented it for many, many times, probably about 80, more than 80 times, but not recently. So it's good to get back into it again. It is a passion of mine. It's been a passion really my whole adult life, the whole issue of creation and evolution. And in about 1986, which is almost 40 years ago, this new theory of intelligent design hit the streets. And it's a theory about science. It has nothing to do with religion, actually, except it has religious implications, as we will discuss. So I have an engineering background. I have 2 degrees from Villanova University. And I also have almost the equivalent of a degree from Drexel in metallurgy later on. In recent years, I've taken courses in molecular biology and paleontology, so I can read papers and understand what I'm talking about and answer questions to some extent. I'm also a Catholic, and almost every time I've given this talk, it's to a Catholic audience. I think there was only one time it was a mixed audience. But there's nothing in here about proselytizing. In fact, you might think at some point here that it's the opposite of that, but that's not my intention. And I think if you're not Catholic, I think you'll find it interesting what the Catholic point of view is on this whole thing and what's going on in the Catholic Church. So the talk is Adam and Eve, Evolution and Intelligent Design. I'm going to mention Adam and Eve a little bit at the beginning, but most of it, of course, is evolution and intelligent design. These are beautiful pictures of God's creation. This little family in the middle I'm going to talk about later on in the presentation. I think you'll discover, I'm hoping that you're going to discover in the presentation these 3 things. There's evidence for intelligence in science, not just by looking at the beauty of nature, but in science, right? Now, theistic evolutionists and atheistic evolutionists tell us that that's not true. There's no evidence for God in science. And there's evidence for God's existence, therefore, if there's evidence for design, because somebody had the intelligence to design it. Who the heck would that be but the God that we all believe in? And thirdly, I want to try to demonstrate to you that Darwin's mechanism of evolution, which is taught in all the textbooks, is not true. It's not plausible. If there's a technique, if there's a way that we're evolving and we haven't discovered it yet, no one has a clue what that mechanism is. I mean, there are attempts to explain it, and in the Q&A period we could talk about that. Now, we know that science cannot prove the existence of God. But science can give us evidence that God exists. So that's what we're trying to do today. Now, 2 sciences in particular that give us evidence for intelligent design are biology, which we're talking about today, and cosmology, which is the study of the universe using physics and astronomy. And you've all heard about the Big Bang and the fine-tuning of the universe, and there has to be an intelligence behind that. But that's not the topic for today. Now, the Catholic Church assures us in the Catholic Catechism that was reaffirmed in 1994, a new version of Catholic beliefs came out in what's called the Catholic Catechism of the Catholic Church, that Adam and Eve are real, and their fall are historically true, the original sin. Yet many of my children, if not all of them, including that guy back there, was taught in Catholic school that Adam and Eve are a myth. A myth. It seems like it's a foundational thing for Catholics and for Christians of any kind. Why do you think that would be? Why would they teach kids in Catholic school that there's no Adam and Eve? I'm sure you would answer that, yeah, it's probably the theory of evolution. That they've come to the conclusion through what their science is teaching today about evolution that there couldn't have been an Adam and Eve. So what is it, and why would it make us doubt Adam and Eve? So the modern theory of evolution, you all know, is natural selection. Based on these small mutations, small changes happen in the genome, and then they're naturally selected to become the dominant version of that creature. And those 2 things can change a molecule into a man. Can you imagine that? A molecule into a man. In a random, unguided way. That's the key, right? Now remember that not even God can guide an unguided process. Therefore, if it is an unguided process, there's no need for God, right? And that is the key and the foundation of atheism in today's world. The question is that true? What is this foundational dogma of atheism? They have their own doctrines, right, and their own dogmas, right? What would make their faith less secure if it wasn't true? Okay, Darwinian evolution, but the unguided part of it. Remember, theistic evolutionists, which dominate the Catholic Church today, they have to say that evolution is guided, because therefore there would be a big problem. The problem is that no one has any clue where to find the evidence for that guided evolution, right? So they take that on faith, that, okay, evolution is true, I'm a theistic evolutionist, but it has to be guided. We know God guided it. Now here's a Discovery Institute research survey in 2016. They asked agnostics in the orange and atheists in the blue, if it were true, what would make, in your mind, God less likely? So what did the atheists pick as their biggest issue? Unguided evolution. 65% was the biggest issue that convinced them to be atheists. It's also the biggest issue for agnostics. Disease and death and suffering in the world, a big problem. People say, why does God allow it? I'm not going to believe in God if he allows it. But this is the key issue, and that's what we're talking about today. Now, why is this important? Can't we just believe that God created by the secondary method of evolution? Why is this so important? Well, what if it's not true? Wouldn't we make a lot of decisions in society and in science and in the Nazis in Germany and both Stalin and Lenin in Russia? The foundational belief of those people, which justified the murder of millions of people, was Darwinian evolution. But the problem for Christians is, so yes, we could, but if it's not true, Darwinian evolution leads to atheism, right? So it is a problem, maybe. And 50% of those who leave their faith, their Christian faith in particular, do so, they say when they take surveys, it's because of science. And 28% of the whole U.S. population are now nuns, which means they were raised in some religious faith, usually Christianity in our country. And they now say, I don't know what I believe. About a third of those are atheists and agnostics. The rest are just floating around out there waiting for intelligent design to come along, right? Now, however, under 30, the statistics get worse and worse. So now we got 40% of people under 30 say that they don't have any faith. Now remember, my generation, this is only about 8%, right? We're getting down, down, down. Now a lot of the statistics were always about millennials, right? Now there's 2 generations below millennials. I don't know, would you guys be Y or Z, or X? There's an X before. You guys are Y and Z, right? You guys, probably Z. Now, for Catholics, it's even worse. 50% of Catholics under 30 are nuns. That's not good. And at least 30% of people born Catholic will, only 30% will remain. And that number goes down all the time. I think it's a lot lower than that now. So that's not good for Catholics, is it? Look at the pews. Look at the way they empty out every year. The average age when people leave their faith is 13 years old. Can you imagine that? It's not college when they take biology. It's not high school when they take biology. They are being poorly catechized, and they're being given a lot of bad example. And they lose their faith at 13 years old. So I'm trying to convince you this is an important topic we're talking about today. What does the Catholic Church teach about Adam and Eve? Well, they teach in the Catholic Catechism that was published in 1994 that they were real people, and that all mankind descended from them. Now remember, my kids were all taught that they're not real people in Catholic schools, even though the Catholic Catechism says they're real people. I could give you a lot of anecdotes over the years. Souls were created instantly from nothing, right? And then Adam and Eve were not subject to death or disease, right? They lived in the Garden of Eden. And they committed the original sin, which we, of course, now live with, brought on the punishment of mankind. These are the paragraphs in the Catholic Catechism where you can find these doctrines. Now, Catholic Church teaches two very important things in addition to those basic things. One is that man cannot be the result of unguided, blind fate or chance. Cannot be. But that's the theory of Darwinian evolution. And the majority of intellectuals in the church are theistic evolutionists. So we're starting to see some incoherency here, right? And they also teach, based on the chapter 1 of the book of Romans, that the existence of God can be known with certainty through his works. We can look at nature, we can see everything, we can contemplate it, reflect on it, and say, how could this come about by accident? This beauty that we see everywhere. So the Catholic Church assures us that Adam and Eve were real beyond a shadow of a doubt, and that at least the unguided part of evolution can't be true. We just saw that in the last slide. But the unguided part is the primary axiom, right? They can't come up with a natural explanation for evolution. They have to have a naturalistic explanation, or they have no theory. They have no theory without God anyway. So that creates a big quandary for Catholics. And this has been going on for not 150 years, but this debate has been reigning for 165 years. And what I want to do is bring you all into the debate. Because Catholics are not involved in this debate. I asked 3 young men that were standing next to me after Mass. We were discussing if any of them ever heard of intelligent design. These were Catholics, Catholic young men. No, never heard of it. We have gatekeepers in the Catholic Church that keep this message away from people. That's a whole nother discussion. But if I was talking to 3 evangelicals, they'd all say, oh yeah, I heard about this. I know what this is about. Now, let's get to the science. I want to make the point before we start that the evolution of molecules to man, how did life begin, where did life forms come from, is totally separate from the age of the earth discussion, the Big Bang origin of the universe. Those are separate discussions. You can have all kinds of flavors of belief on all 3 things, right? They're separate. So we're not talking about the age of the earth or defending the young earth today. We're not talking about the problems of the Big Bang or using it as an evidence for the existence of God, because it was a beginning. There had to be a cause of the beginning. We're talking about molecules to man. A few definitions so we're all on the same page. Evolution, of course, we use that term every day. This person evolved. Their opinion on this particular subject evolved during their lifetime. Or this university evolved from a farming university, or college, I should say, to a great, well-known, nationally known, world-known university evolved. But when we're talking about it from a scientific point of view, we say the word evolution, we usually mean macroevolution. That is that non-life became life somehow, nobody knows, and life to higher life. How did life become all the way up to man, from monkeys to man? Now, intelligent design takes issue with macroevolution, right? Not with microevolution. We see microevolution everywhere. It's change at or below the species level. It's natural variation based on information that already exists. And quick example is bacterial strains that gain antibiotic resistance, and I'll be talking more about that. Natural selection, we've all heard this, right? Survival of the fittest, the strongest lions get to reproduce and the weaker ones don't. No one denies microevolution or natural selection. We see them in nature everywhere. Intelligent design says, wait a minute, as we look at the scientific evidence, we see evidence for intelligence. We see design. We see there had to be a designer here. There's no other explanation for what we see. It's way too complex. It's way too clever. So that's what we're talking about today, intelligent design. Now, creationism is the belief that Genesis 1:11 is literal history and that there's scientific clues there. It's usually associated with people who believe in a strict 6,000-year age of the earth and 6 literal 24-hour days of creation. Now, the Catholic teaching on this issue, traditional Catholic doctrine, is that Genesis 1:11 is a sacred history of events that actually took place, but that figurative language is used in some places. You don't have to take it 100% literal. Microevolution, some quick examples, right? The artificial breeding of dogs, right? Now man is involved here, but he's using the tools that are already there in the genome, and a baby puppy's born and say, hey, we like that long hair, or we like that short hair. So we breed the puppies, and we take advantage of the variation that's already in there. And one scientist right now, he's not an intelligent design guy, he says he believes that there's a mechanism in dogs that makes them unique, and unique creation that we can breed in all these different ways. Darwin's finches, you've all heard about that, peppered moths, right? Darwin's finches, there's a couple called Grant, their last name is Grant, husband and wife. They've been researching these Galapagos finches again in recent years. Have you heard about them? No? You're shaking your head, yes. Anyway, they did, and they found out, hey, this is microevolution. When you change when the season varies, a different kind of weather pattern in a particular season, the new finches will be born with either a long beak or a short beak. Short beak, of course, allows them to break open nuts. Longer beak allows them to get into places that are where the insects live and are harder to get to, right? So the short beak guys, they die out when the other guys, but there's they get a signal from nature. There's an environmental sensor there that allows them to change their beak size. So this was Darwin. This was one of the key evidences for Darwin's evolution. And Darwin, remember, was preaching that if you collect enough microevolution events, you can then create a macroevolution event. And that's what we're arguing against today in this presentation. Now, the creatures grow smaller or they mature early in a fish tank, or there's a lot of examples of this. Fish in a fish tank is one of them. They sense the signals they're getting from nature and they change. Different blood types and skin colors. We all know now from our DNA that we're all related. We come from two actually unique individuals. In fact, science actually agrees with that. There was one mitochondrial Eve and Y chromosome Adam. Right? They say that they lived about 200,000 years ago, and they say they weren't related. They didn't know each other, but they agree. And they said everybody else that was living at the time died, and these two passed on the genes. That's true. You can look it up. It's basic mainstream science. Tasteless strawberries, an interesting thing, right? You get these big, beautiful strawberries. They have no taste. They're sour. How'd that come about? Remember, if you pick fresh strawberries, if you don't make a strawberry shortcake out of them in 2 days, they're starting to rot. But they can sit in a supermarket for weeks because they've been genetically engineered by man. Man figured out how to go in there and shut off a gene that causes them to ripen and eventually go bad. Bacteria's ability to resist antibiotics, I'll be talking about that. These are examples of variation inherent in nature. The key is the information is already there, right? We're looking for a mechanism in Darwin's evolution that adds information, not utilizes information that already exists. That's the key. So what is intelligent design? Michael Behe, he's a biochemist, a scientist at Lehigh University. What is it, about a 2-hour drive from here? 1996, he kicked this whole thing off. Turns out that he's a Catholic, even though Catholics don't know about intelligent design. A lot of the people that are involved in it are Catholic. And he wrote this book, Darwin's Black Box, in 1996, and it was one of the early books of intelligent design theory. He says, let's look at the playroom floor. We see all these Legos. I see this at my house all the time when my grandkids. It's an incredible mess. But anyway, here you look at this and you say, hey, wait a minute. There's evidence of design here. We got this linear gear here, and somebody designed it, so when you turn that wheel, it goes back and forth, right? We say, hey, that's a design. There was a designer behind that. So there's a designer behind this building, this computer, that table, and that chair, right? They wouldn't exist if there wasn't somebody who designed it and then built it. Michael Behe uses his famous mousetrap to coin the phrase irreducible complexity. He says this mousetrap is irreducibly complex. That is, if it has a function, it has 5 parts, and it has a function to kill mice. But if you take one piece from it, one of the 5 away from it, what do you have? A bunch of junk. It doesn't do anything. But Darwinian evolution says you have to have a reason for the first part, and then it gets fixed in the genome. You have to have a reason for the second part, and the third part, and the fourth part, and the 5th part, and it gets fixed in the genome. Oh. But he says, wait a minute, when we look at biology, we see complexity, irreducible complexity everywhere. He uses this famous flagellum that people have been fighting with him now for 20 years, 30 years almost, 1996, trying to say that there's another explanation for this. This is an E. coli double wall bacteria. It looks like somebody designed a motor here. It's got a rotor, stator, a shaft, bearings, and a hook, and a propeller. So I want to show you a quick video of this because it's just an amazing thing. There's about every E. coli bacteria has like 6 or 12 of these. And they help them motor to where they need to get and find it. I'll just play a few seconds of this clip just so you get a feel for it.
Microbiologists have been discovering is that at the level of individual cells, there are little tiny examples of nanotechnology, little tiny machines at work. The flagellar motor is the one that Behe made most famous. It's a rotary engine that powers a whip-like tail, a protein tail, that functions like a propeller, and it moves the bacterium through liquid, enabling the bacterium to essentially track down its food supply. And this little machine includes a rotor, a stator, a drive shaft, a U-joint, bushings, bearings, and a whip-like tail that functions like a propeller. And the machine in some bacterial systems turns at 100,000 RPMs in one direction and can reverse direction on a quarter of a turn and turn 100,000 RPM in the other direction.
A bacterial flagellum is a true nanomachine.
So what we see here is irreducibly complex. You take one of those proteins away and it doesn't work. You have no functionality. Where did it come from? Can Darwin's mechanism of small changes explain these kind of things? The answer is no. It can't. So what is intelligent design again? Well, it's simply the purposeful arrangement of parts. When we see that, we can infer there's a designer behind it. But this guy here, Richard Dawkins, is the most famous atheist in the world. And he says, no, biology is the study of complicated things that give the appearance of having been designed for a purpose. For a purpose. So he's saying, he's staking his whole argument on that one word, appearance. He's also staking his eternal salvation on that one word. Right? If it's not true, he's in big trouble. Now, the real modern movement of intelligent design started actually in 1986. This guy was an agnostic, Michael Denton, which helped a lot with the splash of this book. And he wrote a book called Evolution, A Theory in Crisis. And he tried to tell us that that Darwinian evolution has the inability to explain the history of life, where life came from, and how it becomes something more complex. 30 years later, he wrote a book that was called Evolution, Still a Theory in Crisis. And he's written about 3 or 4 books since then, just explaining all kinds of amazing things in the world around us. And in that book, he gave a couple of great examples of things we see in nature that you can't explain through Darwin's mechanism, Darwinian evolution. And this one was a lungfish. You see what it looks like? It only appears in very hot tropical climates, only is where it lives. And that's mostly in Africa, and there are some in South America. This fish not only has gills to get oxygen from the water into its tissues, but it had a lung. So it can breathe air. And it turns out that in the summer, when it gets really hot and there's no rain, the ponds and rivers where this creature lives dry up and goes away. And this creature goes to the bottom of the pond, he digs a hole and he hibernates. And you can hardly detect any life in this creature. But when the waters come back, this creature comes back to life and he swims and lives just like a fish. You would not know he had that capability. Where'd that capability come from? First time the pond dries up, everything dies. Most things, anyway. And one of the interesting things is this is called a living fossil, right? Which means if you find it living today, and you can find that creature in the fossil record, it's not changed. It's the same as it was. The horseshoe crab on the beach in New Jersey every year is found about 500 million years ago in the fossil record. So it's still the same. This guy is way down the Devonian layer of the fossil record 350 million years ago. It hasn't changed, right? So the rule of the fossil record is stasis. If you find it, it stays the same. And of course, Darwin said, hey, we have all these different creatures. There was transitions in between, but nobody can find the transitions. Now, We're talking here about information. Where does it come from? How do you lose it? How do you gain it? Here we have the wolf over here. A very rich genome. Scientists have studied the genomes, and they say these wild type dogs, coyotes, dingoes, came from the wolf or had a common ancestor. Collies all the way down to Chihuahua had a wolf ancestor. That's what they tell us. Now the problem with the Chihuahua is it has lost a lot of information. It's because of mutation. It's a very weak creature. You can't put this in the wild and expect it to exist, right? You can't take a Chihuahua and go back the other way to a wolf or even to a wild dog. Why? Because the information has been lost. We didn't gain information when we bred a dog. We lost information. We took advantage of mutations, right? So information can be lost by mutation, but new information can only be added if it already exists. And over here we have information that already existed. Here we have this beautiful two babies. They look like identical twins, but they can't be because they have different skin color. These are the parents. One is white. Look at their faces. They look very much the same. One is white and one is brown. Why? Because their parents had black fathers and white mothers. The black race had lost the ability to create a white person, etc., and the same on the other side. But together, they brought information that existed elsewhere back to one place. And now we have these beautiful creatures. This is not evolution. This is taking advantage of information that already exists. So information is a strong argument. The origin of information is a strong argument for intelligent design. Now, Michael Behe says, the only way that we can understand how evolution works is to look at molecular biology. So that's what we're going to do, a little bit of molecular biology. And just so everyone knows what a cell is, what the genome is, and what a chromosome is, here's a cell. It's very tiny. We can't see a cell. We can't see a single cell. We can only see, if there's a 5 of them together, we could start to see it. Inside, of course, is the genome, right? All the DNA, and if you stretched out the DNA, it would be as tall as me. It's about 6 foot long. It would be a strand sitting in front of me, but none of us could see it. And inside there's these letters, right? There's 6 billion of them, A's, T's, C's, and G's. Over here is the chromosome. Humans have 46 chromosomes. And one side of it is where the information is. The other side is an exact duplicate. It's always shown as an X, but when the cell splits, it needs information for the new cell. So it takes that leg of the genome, of the chromosome, and makes a new cell. And then the other side, in the new cell, the other side grows, and now you have the X, the chromosome. You stretch it out, you have this spiral DNA, take a section of it, and you have a gene. And the gene, of course, is then used to transcribe into a protein. They used to think we had 22,000 genes, and therefore we had 22,000 proteins. Just in the last dozen years, they've discovered that we probably have 100,000 proteins because there's so much complexity there that now we can take strips of RNA and actually take them apart and slice them back together. And now they think there's at least 100,000, maybe a lot more. As I said, there's 6 billion of these letters. There's 3 billion pairs, and the information is vast. Nobody remembers a New York phone book, but they used to have phone books this big you could hardly read them. All the phone numbers of people who lived in New York. It would take 2,000 of them to list the alphabet in the DNA. Here we see our double helix DNA. Here we see helicase proteins grabbing hold, opening up, so we can copy one side of it and spit out an RNA transcript that then goes out and takes amino acids and of course creates a protein. Now that motor, there's another motor that's called polymerase, right? It's a motor. Let's take a quick look at how it works.
Transcription is the process by which DNA is copied into RNA in the first step of gene expression. It begins with a bundle of factors assembling at the start of a gene, that is, a linear sequence of DNA instructions. Here shown stretching away to the left. The assembled factors include an RNA polymerase, the blue molecule. Suddenly, RNA polymerase is let go, racing along the DNA to read the gene. As it unzips the double helix, it copies one of the two strands. The yellow chain snaking out of the top is the RNA, a copy of the genetic message. The nucleotide building blocks that are used to make the RNA enter through an intake hole.
So here we have this irreducibly complex machine, right? Where did that information come from? To create those proteins that added to this machine, found it the right spot on the DNA and created eventually a protein. So this is a chicken and egg problem, because remember the DNA has code in there to produce proteins. But in order to transcribe the DNA, you have to have proteins. Where the proteins come that started the whole process, right? Chicken and egg. One produces it, but you need the one that's being produced to create the process. Here's a typical icon of a cell that you see in a biology book. We see the nucleus in the middle. That's where proteins are created. Most of the proteins in there. We see our mitochondria, where the energy comes from in the cell. We see a structure here of spokes, and these spokes are called microtubules. They have a number of functions in the cell, but one of them is to act as little super highways, right? We create proteins over here, but we need the proteins over there. So we have to have a microtubule to get it there. So I want to show how this works. I think it's in the next slide. Yeah, here it is. So here's our microtubule. Here's another machine called a kinesin motor protein. And this vesicle here, this package of proteins have been packed over here in the nucleus, someplace over there, into a vesicle. And this little guy's job is to take it down the superhighway into the cell. Let's take a look at that.
Meet the kinesin. Masterpieces of microengineering, kinesins are miniature motorized machines that carry cargo from one part of the cell to another, walking along self-assembling highways called microtubules. Known as the workhorses of the cell, kinesins have 2 feet, or globular heads, that literally walk 1 foot over another along the microtubule, pulling their cargo to its destination. Each foot possesses 2 special locations, called binding sites, that interact with other molecules. One site attaches to the microtubule.
Is that amazing?
Yes.
Huh? Isn't that amazing? How could Darwinian evolution, starting with a molecule or a bacteria, how could this happen? How could this come about by accident? It's just, when I first saw that, I just couldn't believe it. These, of course, are animations. We can't really actually see these things in the cell, but we have enough technology that we can understand them and animate them. So aren't we seeing design? Even if there's a way to evolve a new creature, aren't we seeing design? Somebody designed these things. There's so much more that we don't have time to talk about. If there's design, then evolution can't be a random chance process. This doesn't just come about by accident. Right? These two ideas contradict each other. This guy, Paul Davies, is an astrobiology guy, astrobiologist. He's certainly not an intelligent design guy. And he's been involved in these conversations down through the years, and he says, how did stupid atoms spontaneously write their own software? Nobody knows. There's no known law of physics able to create information from nothing, right? We're looking for the mechanism that adds information, right? We only see mechanisms that remove information so far. Now here's our double helix DNA again. Of course, a mutation is an error in transcribing the DNA to the next cell, or from one mother and father to the child. A mutation happens there. They're called single point mutations. Now, even if you duplicate a whole gene by mistake, and that's how one of the arguments is for how new information comes about. You duplicate a gene, but now you have 2 of the same thing. Typically, they interfere with each other, right? Like what's the Down syndrome thing? It's an extra chromosome, right? Is it any good? No. It's deleterious. So you still have to go in, even if you have a duplicated gene, you got to go in and change discrete spots to mutate it into some sort of functionality. It typically can create chaos in the gene pool. Now, Michael Behe, our biologist, our biochemist from Lehigh, wrote a second book in about 10 years later called The Edge of Evolution. And this time he said, let's see how far this microevolution, Darwin's microevolution, can advance in nature. If we observe it in nature, maybe we can see how it works and how it can turn one creature into another. And he uses the famous example of malaria and the parasite. So here we have the malaria parasite. The mosquito bites a human. These parasites come into the bloodstream. They go to the liver. And every couple of minutes, they attack the red blood cells, the hemoglobin. And every couple of minutes, they explode and they start to attack the rest. So after about a day, you've got 1 trillion of these things in your bloodstream. And you are feeling very sick. Now, it turns out here's a great example of natural selection. We said natural selection works, right? We see it. Here's a great example. The malaria parasite lives where the blue area is, the light blue area. That's the part of the world where this disease reigns supreme. And the pink is people who have a sickle cell gene. They have a mutation in their gene that gives them sickle cell. That's not good, right? Nature somehow has selected those people, natural selection, to live where malaria lives. Why? Well, it turns out that sickle cell turns the red blood cells, the cream donuts, which has a structure like that with the 4 iron molecules in it, it turns it from a cream donut into a sickle. And that's not good because you're sick. But it has a beneficial effect. If you have sickle cell anemia, you can't get malaria. Right? So some people would say, well, this is evolution. So let's take a quick peek at this one. This will be my last animation.
Sickle cell anemia is a genetic disease that affects hemoglobin, the oxygen transport molecule in the blood. The disease gets its name from the shape of the red blood cells under low oxygen conditions. Some red blood cells become sickle-shaped, and these elongated cells get stuck in small blood vessels so that parts of the body don't get the oxygen they need. Sickle cell anemia is caused by a single letter change in the DNA. This in turn alters one of the amino acids in the hemoglobin protein. Valine sits in a position where glutamic acid should be. The valine makes the hemoglobin molecules stick together when oxygen tension is low, forming long fibers that distort the shape of the red blood cells, and this brings on an attack.
So we see what one mutation can do. Most mutations actually are neutral mutations. You can't detect them. So every mother and father passes on about 100 mutations to the next generation. And every time our cells split, we have at least one mutation. So, well, we'll talk about what I was going to say in a minute. So what's happening? Michael Behe says that this is what evolution can do. This is what mutation can do. It can break things. You see the monkey here escaping from its predators. He burns the bridge. But he's separated himself from that side. Maybe that's where his food supply is. He takes a hit in order to have a beneficial effect. He still survived, right? That's what Michael Behe says evolution can do in nature. It can break something. It can't make something. He goes on. Let's talk about treating malaria. Now, over 200 million people still get malaria every year. 600,000 people die every year. It kills 1,500 people, children, every single day. And of course, science has been trying to solve this mystery for a long time, and they've come up with drugs that are effective for mostly only a short period of time. Because remember that most mutations are single point, and It only takes a year for a new drug for the parasite to overcome the new drug. It only takes a year. Why is that? Because it's only got one mutation to achieve that makes the drug ineffective. Shuts off a port or some access point. And then it's because they have a small genome and they reproduce rapidly. So every time they reproduce, a mistake happens. Eventually they find a mistake that works. Now, what happens when more than one mutation is needed, right? So down here we see the genome. What if we needed a mutation there and a mutation way down there at the same time in the same generation, right? So that would be effective to stopping this drug from working on the parasite. Well, it turns out that there was a drug, and there's still a drug that's being used, and it took the parasite 40 years to overcome it. Not 1 year, 40 years. Why? Because it needed 2 mutations, not 1, at the same time in 2 distinct places. Michael Behe says that this is not likely in human beings because we have a 20-year generational difference, and we have a massive genome compared to the parasite. He says it's going to take man, he can't do it one time in 10 million years. In fact, man would have to wait 100 million times 10 million years for 1 double mutation. Is what he calculated. Now these 2 guys down here took issue with that, Durrett and Smith, and they tried to refute it. They came up with 100 million years. You're not right. These numbers aren't right. That's right. And Behe said, well, your assumptions are wrong, but I'm not going to argue with you. I'll take the 100 million years. Is that going to help? What's that going to help? Right? Now, if you're going to change a monkey into a man, how many mutations are you going to need? How many complex mutations are you going to need? 2, 6, 10 at a time. If there were 6, there's not enough time in the universe, 13 billion years for it to happen once. Right? Now, they tell us that it took the common ancestor from a chimpanzee, this beautiful chimpanzee mom and baby, 6 million years. 6 million years ago, there was a common ancestor that after 6 million years created a chimpanzee on one branch and humans on the other. And their proof of that was, first of all, the DNA is similar, but they only looked at 1%, 2% of the DNA, and they found there's only 1% difference in the DNA they looked at. Of course, this is not true, but if it was true, 1% of 6 billion letters is 60 million mutations, right? Or if it's only on one side, it's 30 million mutations. But now that junk DNA has been expanded, they used to say that 95% of our genome was left over by the process of evolution, over hundreds of millions of years of flotsam and jetsam left over, only 5% was functional. Now, just in the last dozen years, they realized that that's not true, that it's all functional. Some people say, well, it's only 80% functional. Maybe it's 99% functional. Who cares? It's functional. And 1% now becomes 15% in some of the chromosomes, and in the male chromosome, it's at least 30%. To turn a male chromosome into between the 2. Right now, you got to multiply these numbers by 15 and 60. They're 15 and 30, right? So it becomes impossible to turn a monkey into a man. So what we're seeing here is common design. If God was going to have a protein that he needed for the chimpanzee and for humans, the code is going to be the same. So we're seeing common design, not common descent. That's what the evidence is actually really showing. So Darwinian evolution is a theory in crisis. And we're starting to see the evidence that it's not plausible. Darwin's mechanism is what we're talking about. It's not plausible. Maybe there's another mechanism. I have slides that I can show you about some of the other theories that people have, but not part of this presentation. What are some of the arguments? Irreducible complexity. We see it everywhere. You take one thing away, it doesn't work. Probability, of double, triple, quadruple, 20 mutations at the same time, 100 mutations at the same time you're going to need. And they have to have function in order to be fixed in the genome if you're going to turn a monkey into a man. The origin of complex specified, very key word. Somebody specified that information. It's not just a bunch of junk DNA numbers that are out there and somehow organized itself through self-organization into a gene. sequences. Now this is another very famous scientist, actually. John Sanford, he taught genetics at Cornell University. And he wrote a book called Genetic Entropy. Entropy means chaos, right? Disorder. So he's giving us a clue that instead of more order in the DNA, we're going to find less order, right? Now this is 2014, the 4th edition. The first edition was like 2 dozen years before that, in the early 2000s. Now this guy, John Sanford, was a famous scientist. He had a lot of patents that taught scientists how to genetically engineer the genome, called gene gun and other things like that. And he was very famous, and he created a business in order to use genetic engineering to do create genetic modified plants, right? GMO. And he then sold that to DuPont. So now he was a very famous man, very famous scientist. He was a millionaire, and he thought he owed it all to the theory of evolution being true. So his marriage, however, was falling apart, and he went down to a Christian minister. He was an atheist, remember, to get marriage counseling. And he saved his marriage, and he became a Christian. And after a few years being a Christian, he looked at the evidence of his scientific research, and he said, I thought the reason for my success was that evolution is true, and now I realize it's not true when I look at it through different lenses. So he said, isn't it true, right? Primary axiom of evolution is that mutation happens, we know that. Selection happens, we just saw an example. Adaptation happens, right? Things adapt to their environment, creatures, organisms. He says it's clearly not true. Why? Because mutation is degeneration. Selection fails. It's not robust enough to eliminate the negative mutations. And adaptations are superficial, just like with the Darwin's finches. A lot of times they're reversible, depending on the environmental signals that the creature gets from generation to generation. He says mutations are typographical mistakes. There's more than one every time a cell divides. It causes cancer and it causes aging. So somebody my age, they tell me I have something like 50,000 mutations in my skin cells, right? What happens to somebody that's aging? Right? You lose the elasticity, right? We see the sagging skin in our necks and the rest of our body, and we get aging spots and changing colors and things like that. Why? That's mutations. So John Sanford and 4 engineers created this great software where you could put the laws of genetics and the laws of humanity, society. How long does a generation last? How many children does a woman have? How many mutations in a generation? All those things, put them into the program and see how each affects what we see. So here we have the main conclusion. There's lots of conclusions. You can put a bottleneck in there, for example, from Noah and his family if you wanted to. And he says after 5,000 generations, knowing what we know about science and putting the right variables in there, we've lost, after 100,000 years, we've lost about 40% of our fitness. Fitness is measured by length of age, lifespan, and the ability to reproduce. He says we're in bad shape. But if indeed there were 2 original people from which we all came from, by the way, we have 6,000 at least. There's probably 10,000 diseases, right, that we have because of mutations. We don't see a Superman emerging anywhere in the world. What we see is more disease emerging. But if there was an original couple, they would be up here at number 1, a perfect genome. No deterioration. We call these people Adam and Eve. And the Bible tells us that they lived about 300 generations ago, which is only about 6,000 years. So that would be where we are, if John Sanford's correct. That would be about where we are in this curve. Remember that they say that Homo sapiens emerged from animal-type people about 300,000 years ago, right? The first sign of Homo sapiens. And they lived alongside Homo erectus, things like that. That's what they claim. Anyway, so this is saying that after 100,000 years, we would be in bad shape from mutations, especially if it's a small group of people. As he continued his research and his reflections, he's reading his Bible, and he realizes that, Noah was supposed to be 950 years old before he died, and his son Shem was 600. And the other patriarchs of the Old Testament, they create a curve that's just like his program spit out. And here we see, down here, that's Joshua and Moses. They're 120 when they died. And we see our good friend David, King David, at 80. Christ, of course, down here, 32 centuries later, he died of unnatural causes. But remember, they tell us that the people that lived at that time were dying at 40 and 50. That was the lifespan back then, not 73 or whatever it is. So that's 67 generations. So since we're a Christian group here, I thought you'd be interested in those not that science has accepted this or anything, but that's the comparison of the two. So John Sanford says we're devolving. Our genome's getting weaker. We're not getting stronger, as he shows in that icon. So let's summarize where we are. We're almost at the end of my presentation. So irreducible complexity. Remember the mousetrap. We need the information, all of it, that's functional in day one for all kinds of biology in our bodies. We don't have any evidence that we can build it up, maintain it, and use it, and then gain higher function. We have amazing, precise machinery, precision machinery that has no opportunity to learn how to do its job and wait for the next mutation to come along 100 million years later. We have complex specified information, remember, a tremendous amount of software. The information already exists, as we saw in the dogs and other examples. We see evidence for microevolution everywhere, but macroevolution, no, we don't. The laws of probability say no. Multiple mutations is what we talked about. 2 mutations or more, very, very, very difficult. We didn't talk about fixing a mutation. Once you have a positive mutation, how do you fix it? If you have 10,000 individuals in that in the life of that organism, what happens when you have 8 billion people? How are you going to fix a new positive mutation so that everybody gets it? Right? Protein origin, we didn't talk about that. We got maybe 100,000 proteins. The odds of one protein forming by accident, by DNA producing these various strings and hoping one of them does something, is astronomical. Genetic entropy. Mutations are bad. We saw that with malaria. Sometimes they have a beneficial effect. But in general, it looks like we're growing weaker, not stronger. Random chance cannot be true. This is very close to my final slide, but this is a slide from John Sanford again when he gives these presentations. He says, way back in 1859 when Darwin wrote Origin of the Species, we had very little knowledge of biology, way down here. And therefore there was some plausibility to what Darwin was saying. And Darwin had his bumps along the way, but in the 1950s when they discovered the double spiral DNA, the structure of it, and where the information was in the cell. 1950, right? And after that point, Darwin's ability to explain all this just collapsed. And right here is where the genome, the human genome was finally mapped in the late 1900s, early 2000s. And then, of course, the genomes of all kinds of other creatures. The knowledge of biology just skyrocketed, and the ability of Darwin's explanation to explain it just collapsed. And this is all happening in your lifetime. In the last 20 years, this all happened. So how are Catholics reacting to being taught theistic evolution and Adam being called a myth? Right? I think we would all say probably not very well. This is a 2010 Pew Research Center. People under 30 again, they're more interesting. Macroevolution is true. The general population says, yes, 55% of the American population says that evolution is true, macroevolution. But isn't it interesting, first of all, that 45% say it's not true, at least in 2010. Now, Dawkins and the guys in Europe, all the European countries, they look at that number, and they say, what's the matter with these Americans? Because in Europe, that's 85%, not 55%. Why are you people so obstinate? Evangelicals will say only 27% will say they accept macroevolution. And the nuns, these are people now, remember, that have no professed faith, at least a third of them, or either agnostic, they'll say they're agnostic, or atheist. Look at Catholics. They're challenging the nuns in their acceptance of theistic evolution. Is that good? Let's look at people who attend church regularly. The general population, 33%. The evangelicals, 55%. I don't have mainline Protestants here. It would be not a good number, but Catholics aren't a good number either. They're the same as the general population. But these are self-reported numbers. If you ask somebody, do you attend church regularly, they'll say yes, even if they don't. Right? So let's look at the Archdiocese of Philadelphia, where I come from. Right? AOP means Archdiocese of Philadelphia. 2019, there was 17% registered Catholics attending church regularly. So that's just before COVID, right? COVID hit in 20. And of course, after COVID, it dropped. It is, I think, in certain places coming back. I don't know what the numbers are. They don't seem to want to publish them. And it trends down 2% every 4 years. Pretty soon it's going to be zero. The trend down has been a long trend down. Every 4 years, there's at least 2% loss, sometimes 3%. Kara says that millennials attend much less, than that. And that's millennials. There's 2 generations below that. The numbers are always going down. We never see a shift up. And back over there in the land of Darwin, where 85%, accept evolution, only 4% of Christians attend services regularly. So I'm going to conclude right now. I think I've used up my time. I have lots of other slides if we get into different questions. But I hope we can conclude that from the evidence of intelligent design, that God is indeed alive and that he is unimaginably powerful. And that he created us in his image. We know that only because he revealed that to us. And he calls us to join him in heaven for all eternity. So thank you. That concludes my formal presentation. That's my contact information. I have a version of this that is online. This is the better one in terms of the address, but I'm told by Dr. Kaiser that this will be available. My presentation will be available online here. There's a one-page handout that I put together that summarizes my presentation, and that email address is on there as well. So, and Dr. Kaiser has some great books over there that you can discuss. He doesn't sell them, but he recommends them, and they're all great books having to do with intelligent design. So thank you. Thanks for the opportunity to give you my spiel. We can open up for questions. I had some great questions from the young guys I was talking to down in after Mass this morning. Yeah, go ahead. This fellow back here.
If I could open it with one thing, it is actually reversing a little bit. Gen Z attends church more than millennials do.
Gen Z does?
Yeah.
Well, that's good news.
But
and you know why? Is there a reason?
I think they have a higher religiosity percentage.
They see the effects of rejecting religion, perhaps.
Yeah, exactly.
Okay.
The other thing was I wanted to know where you would put the line between macro and micro evolution. Because, to me, looking at, say, bears, it makes sense that they would all go back to, a singular,
of course, the polar bear, right? The polar bear,
exactly.
The brown bear, yeah.
And
this is what Michael Behe says. Let me see if I can find it for you real quick. He wrote a third book. In fact, it's over there, Darwin Devolves. It's called Michael Behe's third book. And it's probably worth trying to find. I forget. Okay. So he wrote a third book, and it's called Darwin Devolves. And in that book, he shows the reasons why macroevolution cannot create a new family.
Yeah.
First of all, he argues that a species and a genus are fungible.
Yeah.
Right? A species today might not be around tomorrow. It'll be a different variation of a species. So he says, we only know, somebody's making their best guess. Is this a species? Is this a genus? Is this a family? So he says that microevolution cannot create a new family. It can create a new species, certainly. A new genus, maybe. And he uses, here's an example, right? Here's Darwin's boundary. Here is the genus, and this is the species. So this gray wolf certainly is related to this guy over here, coyote. And this is the genus here, and of course we know the dogs come, they're the same genus. Even the fox is in the same family as a wolf. So maybe they had a common ancestor. Maybe, we don't know. But certainly the cat, felines and the cat and the dog, next level up, the order, they did not. You can't create, a common ancestor couldn't have created a cat and a dog. That Darwin's mechanism doesn't have enough power to do that. So certainly the bears are very connected. And yeah, here's these two are the same family, the wood thrush and the robin, right? So they could have come through Darwin's mechanism, but this guy, the starling, is a totally different family. And the same thing with the hummingbirds and the swifts. So Michael Behe argues that these could come from a common ancestor, these can't. And wouldn't everybody think that all the birds of the world came from a common ancestor? There's 10,000 species of bird in the world, and there's at least 300 million of them. 300 billion, what did I say, million? Right, there's 8 billion people, 300 million birds in the world, probably a lot more. So what's the largest, most common species of bird in the world? Who can, somebody gets a donut if they, huh? You know?
Chickens.
Ah! Did I put that in there? I messed it up. All right, chickens.
Softball.
Somebody else, what's the next question? You had a question. Did you have a question?
Yeah, my question was like, so, like going back to like the Bible, when we look at like Adam and Eve and then their kids, like where did their kids find their spouses from?
Okay, that's a very good question. I don't have the exact slide for it, but they married their brothers and sisters. Now remember, in the Bible, God didn't tell Moses that you couldn't marry a close relative until about 1,600 years after Adam, because the genome was still strong and robust. But the only reason is nothing. Let's say you lost your sister when you were babies and you met her in Los Angeles and you got married, right? There's nothing morally wrong with that. You didn't know it, right? What's morally wrong is that you're going to harm the next generation. So God said you can't do that. And there's something natural in us when we grow up with our sisters and all that. We have zero attraction to them. Right? I mean, you know, romantic attraction. Not that we don't love our sisters, especially the older we get. I mean, we would do anything. In fact, God puts something in us that we protect, you know, the women in our life. So that's I think the answer to your question. Yeah. And what's the next question? Yeah.
Great. I wanted to piggyback off Leo's question a little bit more broadly. So the way I was taught in school was that one of the biggest pieces of evidence for macroevolution was homogeneous features.
Yeah, right.
So for example, like with the bears, you know, they're all part of different species in the same family. But you can even take different kingdoms, or not kingdoms, whatever the next level down kingdoms is. And if you look at like a whale's flipper or a human hand or a bear's paw, they all have the same structure.
They all have 5 digits.
Right.
Even a bat, right?
Right.
Right. So you call that homology.
Right.
Right. Well, the simple answer to it is common design. Right. There are, of course, creatures with, 2 and 3 digits, but that when they're trying to prove that microevolution produced macroevolution, that's one of the examples they give. But there's no proof that one came from the other. We know that they're commonly designed because those 5 digits have a lot of different uses in nature. So that's what I would say to that question. There's plenty of written rebuttals for that argument. But in general, it comes down to why wouldn't God use, just because he used 5 digits, look at the digits in a wing or in a bat or whatever, they're grossly distorted. They're not necessarily 5 fingers. So I don't have a good slide on that, but that would be the argument, that they're common. There's a common design, not common descent. There's two. You got to look at all the evidence in a group, and then that comes down to a very weak argument at that point. Yeah, go ahead.
Is that kind of like the same argument where I've heard two different people actually tell me that they think like dolphins descended from wolves, and I just kind of thought, I looked at that and I was like, well, I've seen a dolphin and I've seen a wolf, so I don't really think that's right. Or is that kind of the same argument because they think they have
Here's whales. Whales came from a land animal. I do have some slides on that. So this is one of birds evolved from dinosaurs, and whales came from a land animal. These are the two, one of the two very extant arguments that you're going to find in textbooks. So here we have these various creatures that have been found in the fossil record. And the people who believe that this creature became a whale after about 50 million years, right? I think that's about how many million? Well, yeah, that's about 10 million years later, something like that. Yeah. So that 10 million, there it is right there. So 10 million years, you see from this mutation issue, this is going to be a big problem. That's not enough time. So here is this land animal, and here's this whale, right? And just think of all the things you would have to change in that creature to get this creature, right? How many mutations would this get?
And what
Right?
would happen when the one with legs started to lose his legs, right?
Yeah, it would be weak.
Extinct.
Right, nature would kill it. Right. So here we have, this is just a few things. There's a whole article that you could read on how many things have to change in a whale. Tail wagging, kidney issues, nursing babies, forelimbs to flippers, skin changes, has to be impermeable skin, digestive system, eyes and teeth and blowholes and all this stuff. How many millions of mutations would be involved? How many coordinated ones at the same time? It would take 200 million years to make one double mutation. 10 million years doesn't begin to have enough time, right? Now, of course, they found that one of the fossils way down here, this guy here, that they thought was part of the evolutionary transition, lived at the same time as this guy. So the whole thing, kind of goes into the hopper. It's just, I won't waste your time reading those. Uh-oh, what's this? Here's Tim, here's son Tim, and here's my other 4 sons. And I have 4 daughters besides, and that's my wife. And I think we have Amy here. Amy, there you are. That's a separate point that I'm making, but I didn't mean to run into those slides. Anyway, what's next? Another question? Yeah?
You said you studied paleontology. I'm just curious, what do you make of some of the humanoid kind of discoveries?
Yeah, so you have the fossil record, and you have this stuff, right? So the fossil record, you can give a whole presentation on the fossil record showing it has, Darwin knew it had no evidence. In modern times, they don't use the fossil record to prove evolution because it's very, very weak. There's only 3 or 4 transitional creatures that they try to convince us, was a fish to a tetrapod, etc. We argue over that. We find out the evidence is very weak. Then you have these arguments, right? And you say, well, it doesn't look like evolution is possible. So then how could there have been subhumans evolving into humans if evolution is not possible? Well, some people would argue, well, there is a mechanism for evolution. We just don't know it. We haven't discovered it. Other people will argue over the dating methods, and they are very controversial. I would recommend this book here, and it's called Contested Bones, and it is written by our good friend John Sanford, and he looks at all the so-called fossils of early man, and draws some conclusions from them. And I think I can bring up a couple slides on this. So here's our good friend John Sanford again. And John is, he's still active, but his mind is starting to go. He can't remember things. When he's giving a presentation, he has to have actually somebody there to help him bring the term to his, you're trying to say, whatever. What a truly great man. I've had an opportunity to meet him and be with him a couple of times. And he wrote this book, Contested Bones, arguing over the fossils of man. So here's our recent find. It's in South Africa. Thousands of bones of Homo. And they're miniature creatures. They were very small, about the size of chimpanzee. But it turns out that their bones are human bones. So they were saying, that when they first talked about the discovery, they talked about, we can't date them. We're having a lot of problem dating them. And everybody was saying there's going to be millions of years old, but there's got to be, pre-man, they're probably 3 million years old or whatever. This is the cave in South America. The cave entrance, you got to drop down like this. You got to go down here. It's very, very difficult to get through there, and it's almost impossible to get through there. And then there's these thousands of human fossils in there. So they're saying, what in the heck is going on there? Was that a graveyard? Did they bury their people there? Did somebody actually climb in there? So this is down in that chamber, and you see all these bones in there and different geology of it. This is the inside of it. You have to get in there, you got to go down a 12-meter vertical shaft. And this is the skull they found. There's different skulls. It's called Homo naledi. Here's Homo sapiens over here. See the size of the skull. And they were saying, this looks human, but it looks too small. So they finally were able to come up with, using luminescence, a dating on this creature. And where did I put the dating? Anyway, it's like 300,000 years old. I thought I had it on one of the slides, which of course screwed up their dating in a big way. This is supposed to be 3 million years. This is supposed to be a small creature whose brain is gradually getting bigger over the millions of years. So this is the kind of thing you see. Now what our friend John Sanford says is that when small groups of people get isolated, you have inbreeding. And when you have groups of inbreeding, you see these kinds of defects, right? And you see especially this kind of head structure. So this book is all about that. And I highly recommend it. It's really a very good book if you want to get into this and try to figure it out. No one has figured it out, but the evidence is far different than what they present it to be.
So John, I'm hoping we can have some time for informal discussion over refreshments.
Okay.
And so we have a small gift for you. That's a small thank you.
Yes, this is for you for coming out and blessing us with gift from a local artist.
I think it's a picture of Darwin. Since the creation of the world, God's invisible qualities have been clearly seen, being understood from what has been made. In the book of Romans. Ah, there you go. There's my first or second slide. Thank you.
So this event is jointly sponsored by the Newman Club and the Science and the Bible Club. And Lauren is the treasurer, and Peter Murnane, stand up, Peter, is the president. We have a book table over there, but more significantly, we have a sheet to sign up to be on the mailing list. We're trying to host roughly one event a month, so this is not one of these clubs that's doing a zillion things. And if you're on the mailing list, Peter will tell you what the next thing is. In March, I think the focus will be chapter discussions from an excellent book in this genre, which is called The Case for a Creator by Lee Strobel. And we've gone to chapter discussions because students won't read entire books anymore. So chapters are about 30 pages. And so we schedule a time, meet probably in the hub, only got to read 30 pages, and then we can have a good discussion because we have some background from our reading. And anyone who wants to participate in those discussions, we supply the book for free. So if you get on the mailing list, Peter will let you know about that and other things. So that sign-up sheet is over on that table over there, along with some of the books. And the books are books that we have read and discussed as a club. So each year we try to look at different books on this topic because, frankly, most people don't know enough about science, don't know enough about the Bible to carry on a good discussion of this topic. It takes work, it takes time, it takes study, just like learning and growing in your field, which is a major. And you can appreciate Tim is an engineer. Well, you heard tons of stuff that was outside of what he was trained to do. He didn't learn that just by osmosis. That took an enormous amount of time and study. That's the only way you're going to become confident in this field. It's going to take time, it's going to take reading, it's going to take study, it's going to take discussion with people who are open to the idea that God is in this, because the scientific community, of which I am part, I taught 29 years chemistry here, will not tell you this information. So this is a rare opportunity to find out about things that are scientifically true, are largely hidden. So at any rate, thank you so much, Tim. If you want to be on the mailing list, put your name there, and we have refreshments. Lauren brought donuts, we have coffee and some other things. Hang around if you have time and just chat informally. So
Yeah, thank you. And my handouts over there, also a business card. And if we don't get to it today in the private discussions, don't feel, you can contact me anytime and I'll tell you what the world knows about these.
yes, great.
Thank
All
you.
right, thank you, Tim.